Hey y'all, Digital Learning Day, week 4, day 1. Let me get back to my copy here. Number 1 says 12x minus 28 equals negative 63 plus 7. Does this equation have one solution, no solution, or infinite many solutions? The only way for me to tell this is to actually work it out and see. You cannot look at a problem. Most problems you cannot look at and decipher one, many, or none without working it out. So my first step here is going to be to get my x terms on one side of the equation. So I'm going to subtract 7x from both sides. This creates a zero pair here. 12x minus 7x is 5x, and then I bring everything else down. Now I'm going to get my constant on one side, so I'm going to create a zero pair here by adding 28, and I need to add 28 to the other side. This is a zero pair, so I'm left with 5x equals negative 63 plus 28 is negative 35. X is being multiplied by 5, so I need to undo that by dividing by 5. Whatever I do to one side, I have to do to the other side. 5 over 5 equals 1, so I'm left with 1x equals negative 35 divided by 5 is negative 7. X equals 7 is one solution. So the answer to that question is one solution because x equals negative 7. Number 2 says if b equals negative 12, what is b squared? And that would be negative 12 times negative 12. A negative times a negative is a positive, which is 144. So if b equals negative 12, b squared is 144. Number 3 says a line segment has endpoints at 4, 8, and 8, 5. What is the length of the line segment? Here we're going to be using Pythagorean theorem, but we have to get our leg lengths. And in order to get our leg lengths, we can take the 2 points and stack and subtract. Remember that if we get a negative number here, we're going to take the absolute value of it because the distance of a leg or the length of a leg cannot be negative. Distance always has to be positive. So we have 4 minus 8 is negative 4, and 8 minus 5 is 3. And we're going to take the absolute value of this negative. So we have leg lengths of 4 and 3, and we're going to plug that into our Pythagorean theorem. So I would have 4 squared plus 3 squared equals c squared. Remember, c is our diagonal, which would be a line segment between 2 points. 4 squared is 16, 3 squared is 9, equals c squared. 16 plus 9 is 25, equals c squared. We need to take the square root of both sides. The square root of 25 is 5, equals the square root of c squared is c. So c equals 5. So the line segment between points 4, 8 and 8, 5 would be 5. Number 4 says solve for x, showing your work. So the first thing that I see that I can do here is I can combine like terms on one side of the equal sign. So positive 3 and x and negative 7x is going to be negative 4x. And then I bring everything else down. I've just combined those two x terms. So I have negative 15. I can do plus negative 4x or just keep this minus 4x equals negative 43 plus 2x. Now I need to get my x term on one side of the equation. So I'm going to subtract 2x over here, creating a zero pair. And I need to do the same thing over here to keep these equal. Whatever I do on one side, I have to do on the other side. So this leaves me with negative 15 minus 6x, because negative 4x minus 2x is negative 6x, equals negative 43. Now I want to get my constant on one side, so I'm going to create a zero pair here. adding 15 to negative 15, and then I have to do the same thing on the other side of the equation. So don't forget that this sign in front of this number, or in front of this 6x, has to come down with it. So then I have negative 43 plus 15 equals negative 28. X is being multiplied by negative 6, so I need to divide by negative 6 to isolate x on one side by itself. Whatever I do to one side, I have to do to the other side. Negative 6 over negative 6 is 1, so I'm left with 1x equals negative 28 divided by negative 6 is going to be, it's 4.6 repeating, which would be 4 2/3, I believe. And it's positive because a negative divided by a negative is a positive. You could take that, go back and put it back into the original equation, and it should check out. Number 5 says, what is the length of the line segment? And we're given a graph here. So when you're given a graph and it asks for the line segment, you can do it exactly like we did on number, what number did we find the line segment? On number 3, where you can find your 2 points, where this would be point -3,4, and this would be point 5, -2. And you can stack and subtract to find your leg lengths and insert those into the Pythagorean theorem to solve for C, which is going to be your diagonal, which is your line segment here. Or when you're given a graph, you can just count your leg lengths. So we can make this into a right triangle by going down and then over. And, well, I lost it. Here we go. And if I count my units down, I go down 1, 2, 3, 4, 5, 6, and then over, I'm going to go over 8 units. So I know that my leg lengths are 6 and 8. But if I had done the stack and subtract, I would have gotten -3 minus 5 is -8, and 4 minus -2 is 6. Of course, I would have had to take the absolute value of the negative, and I would have gotten 8 and 6, which is the same thing I got when I counted 6 and 8. So then you just take these numbers and plug them into your Pythagorean theorem and solve for your diagonal. 6 squared is 6 times 6, which is 36. 8 squared is 8 times 8, which is 64, equals C squared. 36 plus 64 is 100, equals C squared. And then I have to take the square root of C squared. And if I do something on one side of my equation, I have to do it on the other side. The square root of 100 is 10, and the square root of C squared is C. So 10 equals C. The length of that line segment is 10 units. Y'all have a great day.